everyone, it's Elisa and I'm back. So we are starting the urinary system today. And we're just going to start with some of the basic functions of the urinary system. All right, let's get started. Okay. We'll do gross anatomy again, but I do want to just kind of get into the basics. So, luckily, unlike other systems such as the skeletal system or the muscular system, there's a little bit less to memorize in terms of the gross anatomy. Um, you mainly just have to worry about a set of kidneys, a set of ureters, which are going to bring uh, urine to the bladder, urinary bladder, and the urinary bladder. Also, we'll look over a couple of other items, such as the blood supply, right? And we might talk a little bit more about the adrenal glands, some other functions of the kidneys, right? So they do some cool stuff, like they actually regulate how much blood your bone marrow is going to produce, and a few other really cool things, ion balances and water balances and all that good stuff in the body. Okay. Let me think. Kidney, ureter, bladder, urethra. Yeah, let's talk about oh yeah, sorry. Adrenal gland. Okay, so let's talk about just briefly where they're located. It's gonna feel like kind of like your middle of your back. And so if you were to feel back to the bottom of your rib cage, you'd be feeling like right about where your kidneys are sitting, about at medial position. So the other thing to know is that they're not like really symmetrical. There's going to be one that's up here, and there's going to be one that's down a little bit lower. The one that's a little bit lower generally is kind of just being pushed down by the liver. Liver's huge. Liver's demanding some real estate, and so that's what that is. And right, urinary bladder, luckily, is going to sit right here in the pelvis. Um, it's going to be a little bit different for males and females, but honestly, it's like just a little bit different. We'll also talk about, oh, sorry, the urethra, of course. So the urethra is the part extending out from the urinary bladder that allows for us to finally excrete the urine. And males and females, it's a little bit different, but the truth is, it's not a lot different. We're not super different in the grand scheme of things. So that is convenient when you are studying anatomy. Okay. But there are differences, so we'll learn what those are. Here we go. Okay, so functions of the kidneys. They're going to filter the blood. They're going to excrete toxic metabolic waste, or not just always toxic, sometimes it's just superfluous metabolic waste. They're going to help regulate blood volume, pressure, and osmolarity, right? Ion balance and water and all that good stuff. They regulate the electrolytes, hence osmolarity, as well as they get into the acid-base balance, which is all kind of tied in together with the positive and negative charges of your electrolytes. Um, they also are going to secrete erythropoietin, right, which is going to help us manage the production of red blood cells should you need more. Also, they will help regulate your calcium levels, and we'll talk about calcitrol synthesis. Also, they clear out hormones from the blood, but they also, so they also help clear out, say, medicines, or, especially if you take too many vitamins of one kind or another. So there's that. Have a really cool way of detoxifying some free radicals. And in the starvation state, they are able to participate in the synthesis of glucose from amino acids, which is so serious. And it's not great. It's super temporary. Let me just put it that way. It's super duper temporary, like emergency situation. Okay. So nitrogenous waste, like nitrogen, think nitrogen. And so like, that ammonia type smell that urine has, right? So it's from the like the nitrogen based groups, okay? So that's, part of it. Part of it. Okay, so they're generally wastes. So these are substances that are useless in the body or present in excess in the body's needs, right? We talked about that, like vitamins and all that good stuff. Metabolic waste, urea formation. So we'll talk a little bit about urea. which is used in a few things actually. So urea formation is proteins that are degraded to amino acids, and then like amine, right? The amine group, the nitrogen. See where we tied that all in together. Nitrogen groups are actually removed, and that's what we're going to use to form that ammonia. And then the liver is going, since ammonia is super not good to be circulating in your body, it's going to help kind of cap it off a bit into like urea, which is also not great, but also is more useful and easier to transport in the body until it can be eliminated. Also, is uric acid, which is one of the things that we produce when we're breaking down, right, catabolically nucleic acids. Creatinine, which is another part of the creatine phosphate catabolism. So that's another breakdown product. Blood urea nitrogen, or the BUN level, also tells us a little bit more about like how much circulating nitrogenous waste is in the blood. Basically, how many amino acids and proteins are we breaking down or we have circulating, due to a handful of different reasons. So just like a pocket memorization note card thing, I would put a note card together that says something like the normal concentration of the blood urea is 10 to 20 milligrams per deciliter. So azotemia means that you have an elevated level of blood urea nitrogen, right? Or BUN. You just have too much circulating. And what it might mean is that you have some type of maybe not kidney failure, but maybe getting there. Definitely some renal problems, insufficiency. It can't eliminate this particular waste, or probably other things as well, very reliably. Okay, and so it's like one of the things you can test is you can test for, if you have an elevated level of this blood urea. And what that'll tell us is that, okay, it's not probably only a problem excreting urea. It might also be excreting a lot of things. So we might have like a kidney issue we need to start looking into. Okay, so uremia is a syndrome, which is a lot. So it's a syndrome of diarrhea, vomiting, dyspnea, cardiac arrhythmia, stemming from toxicity of nitrogenous waste, meaning that you're going into organ failure, and so you may need an organ transplant. Okay, so individuals who are having these kind of symptoms like, I just feel really sick, and maybe like lightheaded a lot, cardiac arrhythmia, all that stuff. Check kidney function. Okay, so major nitrogenous waste that you're gonna see, and you don't have to memorize these chemical structures, but it's a good idea to know what they are. And this is ammonia, and so I would know it's like NH3. For that, that's like basically it. This is a little amine group there. Okay, urea just has it's a couple of amine groups, centralized by carbon oxygen, right? So it's really reactive whenever you see this double bond right here. Uric acid, also a very reactive substance, and creatinine as well. So just really the take home message is you should look for the nitrogens, like a lot of that. Okay. Um, that's usually the most helpful thing whenever you're being tested on these. So we'll show you things like sugars, we'll show you things like, deoxo, like DNA would probably be a hard one, but it's in there. So just there's that. Excretion. So separating the waste from body fluids and eliminating them, that's what excreting something means. And there are four systems that we actually can like push out or excrete things that we no longer want in the body or are harmful. Okay, number one, we just looked at. We just looked at this one, the respiratory system. So it can get a lot of gases out, but mainly it's like CO2 bubbles we need to get rid of. And some water loss, and then not like tons of water loss. So like the integumentary system is crazy because you will sweat out, or you will like create oils or all these other things that you can, all these other types of ways we're excreting. And it's reasons why we have this kind of like salty taste, right? So and other things that we excrete also, which are important for things like microbial climate management on the body and like scent communication between other humans, which we're just starting to figure out. And I'm totally not going to get into in this chapter, but it's out there. So there's that. Also, we actually do lose a lot of water from integumentary system. Okay, the digestive system also big one for water. We get rid of like a lot, like things that come in that we can't use too much of or can't digest is going to come back out. So salts, some carbon dioxide, fats, bile, cholesterol, metabolic waste, and also like fibers and bulk, and so all of that. And then finally, here we are. This is where we are today, is urinary system. So lots of metabolic waste. So you're going to see, you're going to be able to test urine for some very specific stuff because the urinary system is a little bit different from all of these in that it's like a filter, right? It filters, it tests, it's constantly circulating the blood through it. So it's constantly measuring some of these like very like smaller chemical components, right? So things like toxins, metabolic waste from, say, maybe drugs that you've been like taking, or vitamins, or even just your food, or even just breakdown from all kinds of catabolism in the body, and then also hormones. It pulls out the right amount, and it actually pushes a few things back in there. Again, it really does a number on salt and hydrogen, acidity, right? It's acid-base balance. And then, of course, water. Okay, so yeah, that was it. That's the last slide. So I hope that was helpful, and I hope you are having a really nice day. And if you have any questions, email me. All right, well, have a great day. Bye-bye.